Hello students, so in this lecture we will discuss about Zeeman effect. Now a spectral line emitted by an excited atom is split into a doublet or triplet. So a spectral line emitted by an excited atom usually either is split up into a doublet. This is the line. It will go into two lines. It's a doublet. So let us put it that way. This is the spectral line. So it is split up into two lines. This is the original line. So these are two extra lines. So this becomes a doublet. Or it can also become a triplet, or even a triplet. This will happen when the atom is placed in a magnetic field. This splitting of spectral lines is what we know as Zeeman effect. Now, to produce Zeeman effect, what we first require is a source of light. There should be a source of light. That source of light can be a sodium lamp, or a mercury arc, it can also be a gas discharge, in a tube which is called a bi-slit tube. And when this is placed between poles of two powerful electromagnets, so it looks something like this. So this is the tube. It is placed between two electromagnets. These are the electromagnets. This is the tube. The light coming from the source is examined by means of a spectroscope. So light is examined by means of a spectroscope of high resolving power. In order to view the light parallel to the field, a hole is drilled in one of the pole pieces along the axis of the magnet. So light parallel to the magnetic field, hole drilled. So here is a hole is drilled in one pole pieces. Now, when there is no magnetic field, the spectroscope is on the one of the lines, the spectrum of the light. So, however, when the magnetic field is applied, there are few observations. So, the first observations when magnetic field is not equal to 0. So, the first observation is when the light is viewed in the direction perpendicular to the magnetic field, three components are observed. And out of these three components, as I've shown you in the first case, this is the original one, and these two are the two ones. So if there are only two lines, you get a doublet. If you get three lines, you get a triplet. So when we are observing it perpendicular to the magnetic field, we are basically getting a triplet, and this is the original line. Now another observation is that when these outer two lines, are observed by means of a nickel prism, as an analyzer, the lines get polarized at right angles to the undisplaced lines. To the original lines. Bipolarization means either one of the electric, we have two components of light, electric and magnetic components. So either one of them remains, another one gets diminished. So this is what is known as transverse Zeeman effect. Now there is another observation. So this observation number 1. Another observation is when we are, this is 2, when we are observing the light parallel to the magnetic field direction. So in this case we get a doublet, which means we get only two lines and there is no original line. Only two lines are observed. So this is basically a doublet. And these two lines are also circularly polarized. In opposite directions. And this effect is called the longitudinal Zeeman effect. Now, so this is observation number 2. Now, this Zeeman effect is explained by means of Lorentz electron theory. So it's called LET. So we will try to understand what this Lorentz electron theory is. So that's with Lorentz electron theory. According to Lorentz electron theory, an electron moving in circular orbit of radius r with velocity v. So this electron is moving with an radius r, velocity v in circular orbits. Then the centripetal force is given as F v squared by r. Now in this case, if we apply and external magnetic force which is directed perpendicular to the direction of motion of the electron, perpendicular to say v, so we get a force V1. V1 is the force, addition of the force. Now, when the force is acting inwards along the radius, the velocity of the force increases. So, force acting inwards, velocity increases, or when the force is acting outwards, naturally the velocity decreases. Now suppose this is force that we are getting due to the magnetic field. So, and this force is directed towards the center, so we get a total force total force along the radius is mv squared by r plus VEV1, and we can call this one as equal to mv1 squared by r, where v1 is the velocity after the magnetic field has been applied. And so the equation on simplifications we get right, v is equal to r into omega, where omega is angular velocity, and v1 is equal to r omega 1. Then on simplifications, what we obtain is omega 1 square minus omega square is equal to EV omega 1 divided by m. So we can have omega 1 minus omega into omega 1 plus omega. This is equal to EB omega 1 by m. So to get omega 1 minus omega is equal to EB omega 1 divided by 2m omega 1 plus omega. Now omega 1 plus omega, if we take this one as approximately equal to 2 omega 1, so we get omega 1 is equal to omega plus EB by 2m. So omega 1. Okay. So this is the equation we obtain. Now if we again write omega 1 as equal to 2 pi v1 nu1 and omega is again 2 pi nu2, so we get omega 1 is equal to nu1 is equal to nu plus EB by 2 pi m. So, and this is the final equation. So you can see that it is due to this magnetic field and there is a change in the frequency. Now this is for omega nu1, where we have assumed that the velocity of the electron is adding to, or the magnetic field or the force is adding to the force of the already existing centrifugal force. Now if the electron moves in the opposite direction, okay, then using the same principle we can have omega nu2 we can put it in the form. We obtain 2 pi omega 2 minus omega is equal to EB by minus EB by 2m. Here we will consider that omega 2 plus omega is equal to 2 omega 2. So we obtain the omega 2 minus omega is equal to minus EB by 2m. So it's obtained nu2 minus nu is equal to minus EB by 2m. So from this equation and from this equation, if we compare these two, we get delta mu is equal to EB by 4 pi m. That means mu1 minus mu2 is equal to EB by 2 pi m. So this is actually the main equation. So this is how there is a change in the frequency associated with the magnetic field, and this is what we know as the Zeeman effect.